Welcome back to the DASYLab training. This training will make the most sense if you have watched the previous modules. In Module 8, we'll do some advanced data file topics, the black box module, the action module, the message module, and program startup and shutdown. When we look at saving data with DASYLab, these formats are commonly used for saving data. The DASYLab file format is a binary file. It is the smallest possible file size for DASYLab. It is efficient simply because it reflects our internal data usage block configuration. ASCII data, text-based file formats, whether it's a CSV or a .txt file, is fairly verbose because it takes what could be binary data and expands it out into readable characters, each of which may take 1 or 2 bytes to render the same information. However, ASCII is the most portable data file format because it can be read and processed by many, many programs. Not very many programs can read DASYLab file format. The third one I want to look at is the National Instruments TDM, TDMS Technical Data Management and Technical Data Management Streaming files. This is an alternative to using DASYLab, where you can create a binary file that can be read by many, many more applications, notably, of course, the National Instruments applications, but there are also many other programs that are compatible with it. National Instruments includes an Excel ability to read from a TDM file, as an example. So we'll start by taking the write data module. We'll use a global string in the file name. We're going to ensure that enter on experiment start or measurement start is checked. And then we'll set up 3 different write modules, one for DASYLab, one for ASCII, one for CSV. And then we'll compare the file sizes and the ease of opening with Excel. I'll use the measurement computing USB 201 for the data device. So I'll get data from channel 0. I don't need to change any of the settings here. I'll click OK, close the input-output group, and open the files group, and I want to do a write data. The write data group allows me to select the number of channels and the file format type. Initially, let's do DASYLab. I'll click on Options. The DASYLab format doesn't have a lot of options, mostly which global variables and strings you want to store in the header, and then whether you have multiplex data or not. The precision of the floating point values gives you the choice of single or double precision. I'll choose double because that would be the largest binary file that DASYLab would create. I'll click OK, and now I want to set up multi-file because I always do that. I'll enable append to file chain and set the number of blocks to 0 so that it only creates a new file when I hit start. Now, the file name, I had said let's use a global variable or global string. So I'm going to use global string number 1, which is not yet defined. That's okay. We can click OK, wire this up, and configure the global string in the global string dialog. The shortcut button number 2 is the quick way to get there. So I have global string number 1. I'll give it a quick description. So this is the data file name. I'll give it a name, data file. And I'll configure it to prompt at the beginning of the measurement to enter a value. Input is required. This is a file name. It can't be blank. And because I'm going to use the entire string for the file name, I'm selecting file selection. And then you have to tell DASYLab whether you're saving it or loading it and what file type it is. So I'm going to use DASYLab as the file type. This is important to remember because now this is specific. Click OK. Now that's configured. I want to do one more thing. I want to set this up so that I can really compare the sizes of the file by having exactly the same amount of data in the file. I want to set up a stop module to stop after 10 seconds. And it will stop the measurement, and then the file will reflect 10 seconds worth of data. In order to do that effectively, I try to ensure by copying inputs that I've seen 10 seconds go into the file. So I've set it up that way. I don't have any modules to display the data, so I'll just hit start. I can enter a name, or I can click the file button to select and enter a name. So this is going to be my new file, .ddf. And DASYLab will automatically put the rest of the path in here, and I'll click start. The data is being written. In 10 seconds, it will stop. And we'll look at the data file. So the data file after 10 seconds is about 85 KB. Now I want to compare this. So the next thing to do to compare is simply to change the write module, open its properties, change it from a DASYLab file to DASYLab's ASC format. Now there are many more options than an ASCII format. I like to use tab as a separator when I can. I want to specify more decimals than DASYLab normally does, and I want to store the date and time in the file. So this is often typical of what you might see when you're storing data to an ASCII type file. I'll click OK. Now the file type is wrong in the global string. So I need to click OK, go back to the global string dialog, and change the global string to match the file type that I'm using. So this is all set up. This isn't something you're going to do every time you run, but only to do the compare and contrast today, I'm switching between the file types. So click Start. It's going to prompt me for the file name. And now when I click on the File button, it offers me the original file name appended to ASCII. And so I need to remove the .ddf, click Save, and click Start. And so in 10 seconds, I will have another file. So I'm creating an ASCII file. And at 10 seconds, the file is 323 KB. So that's considerably larger than the ASCII file. Now, I had also said, let's try this with a CSV file, since more people seem to use CSV. So I'm just switching it to CSV. It gives me the warning on CSV. The default options for CSV change the timestamp to measurement seconds, but otherwise it kept my number of decimals. I'll click OK. I have the same problem with the file name, so I need to click OK, go into the global strings, change the file name properties to store it as a CSV file, click OK, click Start. I click the File button in order to get the extension correct. I really do want it to be a CSV file. So I'll click Save. Now this time I'm going to check it. I'm going to go to the end of the string and verify it's my new file.csv. I'll click Start. We'll wait the 10 seconds. You can see I now have a CSV file being created. Now you note the file size isn't updated while we're running, and it's not updated until the end. Now this file is half the size of the ASCII file, mostly because the timestamp is seconds. So in the My New File ASCII, if I look at this in Excel, you can see that the timestamp includes a column for the date and a column for a time. And each one of those, I always change this, each one of those file format or columns adds characters. So I want hours, minutes, and I've got 3 seconds, or 3 zeros on the seconds in order to show milliseconds. So that's the full timestamp. So there are far more characters associated with this data than there are in the CSV file. So we can look at the CSV file. And you can see the CSV file only has 5 or 6 characters for the time and the same number of characters for the data value. So it's considerably less data when you look at it side by side. Each one of these characters, the date and the time, take up space. So if file size is a constraint to you, you want to consider that when you're looking at what you store in your ASCII file or your CSV file. So storing the full date and time is a file that's twice the size than just storing the elapsed time. Now that we've looked at the difference between DASYLab and text files, let's look at storing the same data as a TDMS file and then importing it into Excel using the NI tool. So I'll change the module properties again, and this time we will select TDM, and we'll do the NI TDM streaming. Now, if you're familiar with the NI Technical Data Management formats, you've got a number of options that you can set up. And part of the power of TDM is the ability to document the data so that you can include properties for the module for each channel header and for each channel group and any channel custom properties that you need. The NITDM format defaults to double precision data, 64-bit data. So this is the streaming format, which is a binary component with a readable header file. We're still going to use the same data file name, but we need to change it in the global string dialog again. So we'll go to global string and change this from ASCII to TDM streaming. So the NITDM streaming. So that will append tdms.tdms to the file name. So click Start and click File. And I'm going to get rid of the CSV and click Enter. And then we're just doing the verify thing. It gets TDMS appended to it. Click Start and let's wait the 10 seconds. Let's look at the files. So now I have a new file called TDMS and a new file called TDMS index in the folder. So I'm going to open it by double-clicking on my new file name. When I installed the NI TDMS importer for Excel, it associated this file type with itself. So opening it up will open up Excel and it will import in. And you can see when I import in, I have 2 sheets. The top sheet is the root, which gives the context of the information, the root name, the title, which was the module name, the author of the file, DASYLab, the date and time that it was created, and any other information, including, in this case, the company. This flowchart doesn't have a name. And then the channel groups that are included in the data. So the group is called default time. And when I click on the sheet for default time, it has got a time column, and then it's got the data column of the data associated with the time. And I should have the same 10,000 or so samples in this file that I had in previous files. So this actually ran a little long. It ran until about 11.5 seconds of data, or 10,500 samples. So let's just close that file. Don't save it. And let's look at the files again. The other thing we wanted to do was see how big it is. So as a binary file, its size is comparable to the DDF file. The DDF file includes its own header information, and in the case of TDMS, it creates it as a second file. Now, if you wanted to make it a readable TDM file, We would change this from NITDM streaming to NITDM. The same options are available. So you can say that the module name is the module name or it is a global string. So you would fill in all these properties using global strings that you previously configured. I click OK. I'll click Start and give it the 10 seconds. And look at the files as it's being created. This is being called a TDM file, and the companion to the TDM file is a TDX file. So the NI formats all save two files. Now if I double click to open TDM in Excel, you'll see the same two tabs. So we've got a sheet for the root and a sheet for the time. So the data is the same information. The difference here is that the file, the file is still pretty compact. So TDM is the header file, TDX is the data file, and Excel opens it up very cleanly. So that's how you would want to do Excel-based data if you wanted to store data in Excel. Let's look at storing data to Excel directly using DDE rather than storing as a file. A lot of people want to do this. I do strongly recommend that you store data to a file and then open it in Excel rather than writing directly to Excel. The DDE technique is a technique that Microsoft has said for years is being discontinued. So at some point in a Windows operating system in the future, DDE will not exist. In the meantime, we can continue to use this 30-year-old technology to have two applications talk to each other. I'll create the DDE output module, and I'm going to set this up by specifying the client as an application. The easiest way to do this is to select it using the server button. The Excel program has got to be running in order for DASYLab to be able to communicate with it. You need to know the name of the program, Excel, and then the target sheet that you're going to write into. So I have a new book open that's by default called Book 2, and the sheet is Sheet 1. Once I've done that, I need to be able to specify how I'm going to write the data. I would like to generate a row column notation to be able to write the data. And what do I mean by that? If I open Excel and look at it, the first cell in the upper left-hand corner is labeled A1, but you can also think of it as row 1, column 1. The second row is row 2, column 1. The second column, second row, is row 2, column 2. So what I'd like to do is write the time in column A and the data in column B, or go from row 2, column 1 to row 2, column 2. I'll do that by clicking on the Item button. In the Item button, I can create a range that DASYLab will automatically increment as we count through the rows. So I just said I would like to store data in row 2, column 1, and this is tricky. A lot of people don't get this. I'm going to put a colon in here and put an R again, because row 2, column 1 is where I'm starting, and then row 2, text part C, column 2 is where I'm ending. Now, DASYLab lets you preview this. If you look at the bottom where it says Item Preview, it shows you row 2, column 1 to row 2, column 2. The next thing I need to change is this increment stuff. I'm going to change the increment after 1, and I'm going to turn off the restart. And now this will, if I check with the preview item, I can see that it's going to count up by row. The row is changing, the column is not. So the column information is fixed. I'm always going to write the time into column 1 and the data into column 2. I have to click on the Format button to say I need to create a time channel, and I can either use the real time or measurement time. The separator can be a space, a tab, a semicolon. It's better to use a tab with Excel in the US, and we'll pick up the decimal separator from your operating system. Click OK. Click OK. I'm going to wire this up. I would like to have a copy inputs on it so I can do the 10 seconds thing that we did before. Now I'm going to have Excel open at the same time so you can see what's happening. So I'll make Excel a little bit smaller and I'll hit Start on DASYLab. DASYLab is still asking for the file name even though we're not using it. So I'm just going to click Start and bring Excel up. And so what DASYLab is doing is it's writing a timestamp using Excel's time notation into the first column. And then it is writing the data into subsequent into column B. So if I scroll down to the bottom, you're going to see that I've got 106 rows that have been written, and the data has been stored. Now, what's happened? 106, not 10,000. Right now, DASYLab is writing one value per block. I can fix this by changing the right data to change the measurement, not the right data, the analog input to go to 10 samples per second, and the block size is 1. And now when I do the 10 seconds, it's going to do the same thing. By the way, it's always going to start at the beginning. So I'm overwriting the data again with the current time. It's going to come down and write all the way to the bottom, and it should stop at about the same spot. There it comes. So we've got 106 values or 100 values for the data as opposed to 10,000. So we've got the data here. This column needs to be formatted as date and time. It's real quick. You can do that by going to date and say short date and then go into format cells. And in format cells, you can pick a date and time format that will allow you to display the data. I'm looking at the timestamp and wondering why Excel has just got 1400 here instead of the hours, minutes, seconds. I think I need to go in and format cells and pick a custom format to force Excel to show seconds and then the fractions of a second. I'm only going to use 10 because this was 10 samples per second. So now I am seeing the data that was stored every second with the correct timestamp on it. There are a lot of variations on how to use DASYLab and DDE, and I put together a number of DDE examples at Measurement Computing's website, www.mccdaq.com/DASYLab-resources.aspx. On the DASYLab resources page, we've got links to a number of examples, including very specifically some links to DASYLab DDE examples. These examples are set up, it's part of a PDF file and a knowledge base note that if you were to open up the DDE examples, you would see that we've got examples for how to write Excel at higher speeds, reading from Excel at higher speeds, sending commands to Excel, and starting Excel with a file name. So I wrote this. The examples are on the downloads page. So if you go to the ftp.mccdac.com, you would open into the examples for DASYLab and the DDE examples for DASYLab 2020. Note that I did different examples for each release, are in a subfolder. And so here are the worksheet files, a big data example Excel file, and a DDE example Excel file. The PDF file that we had just displayed is also included here. So this may help you if you really want to use DDE and be able to use it effectively with DASYLab. Let's talk about black boxes. Black boxes are a technique for helping you to manage your worksheet
It's an organizational feature, not a classic programming feature, in the sense that a black box is simply another level of the worksheet. It's not a self-contained level. It is aware of the entire worksheet as well as the worksheet is aware of anything in the black box. So it creates a worksheet within a worksheet. You can use it to implement standardized module configurations. It makes your main worksheet easier to read and change. You can save and reuse black boxes that you've standardized on. You can password protect the black box, and you can nest black boxes down 255 levels. I'm not sure I'd ever consider that, but I've certainly seen worksheets that have gone down 5 to 10 levels. Makes it a little bit harder to figure out what you're doing, but it also makes the top levels of the worksheet easier to understand. You can organize your worksheet with inputs and outputs, with data processing functions, with file saving functions, with emergency functions, with the various control functions. You can separate all that out. So we'll do an example with making a simple black box just to get you familiar with it. And then I will show you a more complex worksheet that I've set up with black boxes to provide the complexity control.
To create a black box module, you go to the Special group. In the Special group, you drag out an empty black box. A black box initially has no inputs and no outputs. When you open its properties, you don't get a module dialog box, you get a separate worksheet layer. If you look at the title bar of DASYLab, you can now see the DASYLab knows that I'm in a black box. It would be the worksheet name, the black box name, and then I'm in the worksheet view. You can change the color of this background if you want to. What I need to do is be able to import data into this black box and export data from it. I'm going to use the export import module and drag out the module. It's modal. You pick import. And what I would like to do with this little example is show you one way to improve the complexity of the worksheet. So what I want to do is I want to take the input and I want to do statistics on it the way I did in the statistical values example. So I'm going to set up the statistical values module, and I'm going to do this very quickly. First of all, I'm going to select channel name and click F7. So for the first channel, I want it to be the minimum. I'm going to use the F12 key to jump ahead. Maximum on channel 1. I'm going to click F12 again, and I'm going to pick RMS. F12 again, and I'm going to pick mean. F12 again, and I'm going to jump down to peak to peak. And now I'm in the channel name field, and I need to change this to say that it is peak to peak. I'm going to click the F11 button to go backwards, erase the value, and this is mean. F11 to go backwards, erase the value, RMS, and repeat until you have named all the channels. I'm going to set this up to do just a simple blockwise minimum, so I don't need to make any other changes. These are all going to work the same way, one value per block of data. Now, the reason I'm doing this is because in order to do this kind of a function, you end up branching the wire a lot. So I am going to wire this up. And connect it completely. And now I need an output black box. So I'm going to do the export import and do an export. And I need to output 5 channels, 0 through 4. And I will connect that up. And now to get out of the black box, you don't have to close DASYLab, really. You can click the close the black box button that is now a dark brown color with a green arrow on it, or you can go to the edit module black box and say close black box. So now I have a black box module that has 1 input and 5 outputs. I can do an analog input from the measurement computing group. I can connect it, and I'm going to just use the one channel, wire it up, and display it. And now compared to what this was like in the original statistics example, this is much simpler. I can now move this group of modules around if I need to. I don't have to worry about the individual wiring, so I can pick this up and move it around if I need to and rearrange it as I need to. So I'm going to restore the digital meter. I want to configure the digital meter so that I can see the channel names, and I'll make the unit in the same row. Click OK. So the analog input is at 10 Hertz, 1 sample per block. That isn't very meaningful if you're doing a statistics on 1 sample. So I'll switch this back up to the 1,000 samples per second with a block size of 100. So every 10th of a second, we're going to get a statistical values update. And so that's moving nicely. While you're running, I can open the black box and I can look at the module. So I can open its properties and I can see the function that it's doing. I can change the function that it's doing dynamically, but I can't change the number of blocks. So I'll click OK, I'll click Start. What I would like to do is change the number of blocks to work over 2 seconds. So I'm going to do 20 blocks of data. I'm going to click the F7 key, function 7, and copy that value to all 5 channels. And now notice what happens when I hit Start. I am in the black box. When I hit Start, DASYLab will close the black box and go up to the top level of the worksheet. We can test this by changing the amplitude on the incoming signal, and you can see that the maximum and minimum change along with the value. And the peak to peak reflects the maximum to minimum span. So that's a simple reason for using a black box. It allows you to control the complexity of the worksheet. Now, one of the things that I noticed was that there is no properties dialog to change the channel name. To do that, you have to go to the Edit menu, Black Box, and Black Box Properties. And you can give this a name, and I usually start with a lowercase bb and call it something like statistics. And this is various stats. And it requires an ID tag, and we don't use it anymore. So I'm just clicking BBB. So now you can see that DASYLab up on the title bar calls this BB Statistics. If you go back up to the worksheet level, it's now called BB Statistics. Double click on it to open it again, and go to the Edit menu, and go to Black Box and save it. It will default to saving it in the DASYLab folders under Black Box, and I'm going to call it Statistics. And I have now saved a copy. So I open the folders and I move up to the ENG folder and look at the black box folder. You can see that there is now a statistics.ddb file stored in the folder. DASYLab also, when it installs, automatically creates a gray code encoder for you. Now, what can I do with that? Well, let's go back to the main worksheet level. I would like to add a copy of that to my worksheet. Up at the top of the module browser, there are 4 tabs. You can click on the black box tab, open it up, and you will see all of the files that are stored in that black box folder. If I drag statistics out, it will automatically create a new statistics black box. If you open it up, you will see that it is the same thing, including the module names. So it did not increment the module names DASYLab might complain if you open a module and click OK, it may say that the module name is already being used. So even if you use this, we still make you work a little, and you would need to add context to the module name. If I replicate the logic, I can copy the digital meter and paste it. Then I've got a second digital meter here that should show, with luck, exactly the same data. So why would I do this? Well, in one worksheet, for example, I'll stop the measurement, go into the second statistics box, and change the computation to cumulative. So I'm going to click F7 here to copy cumulative to all 5 channels and click Start. And now my first one is constantly changing as my data changes. And the second one is going to hold that data at the peak. So the peak minima, the peak maxima, and then as I increase the amplitude, you can see they both peg out, and the original statistics is changing, but the second one is not. So that's just a quick look of how black boxes look. What I want to do next is show you some examples of black boxes that I've used in the past. So I'm going to do a file save and save this as statistics, black box. I've opened up this example worksheet that uses black boxes. It's also a worksheet that demonstrates how layouts work. But what I wanted to do is use it to show you how I'm handling the complexity of the logic. I am controlling channels independently and doing computations for each channel independent of the others. The worksheet is set up so that it has a control switch to select the display. It has a start-stop switch. It has an action-controlled relay where you can use the action module to turn on or turn off individual channels. When you look inside the black box, these are all virtually identical, where each channel has got some control logic to be able to control the transmit and block of the relay. And then it's got the same kind of statistics that I've just been doing, where I'm doing a max, min, mean, RMS, and max position. And I am doing that for each channel independently. If I go back up to the top, if you look at channel 3, it is the same logic. It's rearranged a little because of the way I did it, but it is substantially the same logic as the other channels. So I'm going to hit start, but before I do that, I have to stop the recording and go to full screen recording so you can see how this looks. So I moved this to my main monitor, where it turns out the display modules were hanging out anyway. I'd set this up so that I have an overview and then a channel 0, channel 1, channel 2, 3, or just the worksheet view of the data. I had also added some simple logic here to show how long this worksheet's been running and whether it's running or not. So if this status lamp is not blinking, the worksheet is not running. When I click Start, DASYLab is going to switch into the layout view because that's the way I designed this. And then I am using this coded switch at the top to determine which display I'm looking at. I'm looking at the main display. I can look at channel 0, 1, 2, or 3. Right now, all the channels are off. If I start channel 1, you'll see on this second chart recorder that channel 1 is starting to display data. If I click channel 3 on now, channel 3 is now starting to display data. If I look at the channel 3 main window, this chart got reset, so it always starts where the data started. And I'm doing the running computation of the maxima and minima. In this case, it hasn't deflected off of its rectangular waveform. So now you're seeing that it's a -4 minima, and the mean is changing as time goes on. If I click stop on this channel or stop off on the channel and click on the channel, you'll see it resets and it starts up in the cycle where we had left it off. I also had channel 1 on. Channel 1 is continuing to increase. If I turn it off and turn it on again, then it will start at a higher point and it will start doing its computation again. So this is an example based on a customer that I had worked with who was doing exothermic reactions and measuring the time to maximum. You'll note that I have the uptime for the entire worksheet and that the worksheet is running. If I go back to main, I have control over all the channels. You can see the gaps where I had stopped the measurement. I can turn them all off again, and then I can turn on the one that I want to look at. So this is an example worksheet that uses black boxes to manage the complexity of the worksheet, and it uses layouts to also manage the complexity by giving you the ability to look at an individual channel. I'm going to turn it off, and I'm going to stop the measurement. DASYLab is configured to automatically go back to the worksheet view when this worksheet stops.
The action module is very important to DASYLab Full and Pro. It gives you the ability to control how different modules work and how DASYLab works. You can use a reset, a change function, a set values. Depends on the module and how the module is configured. If you have a worksheet with actions, you can see the list of them in the Worksheet Options view under List Actions. In addition to module-specific actions, you've got DASYLab general functions, such as controlling displays, layouts, changing strings and variables. If you don't have DASYLab Full or Pro, you still have access to some of the actions, but instead of being based on an input to the action module, they are based on keys or key combinations, so they're events without the action module. So I want to configure the action module to load a full screen layout on project startup. I want to take the statistics example that I just did and add some charts and add some layouts to be able to switch between the layouts.
I took the statistics and black box worksheet that I had just worked on and I added 2 chart recorders, one for the running statistics and one for the cumulative statistics. And then I added a chart recorder to display the raw data before it went to statistics. I created 3 layouts. The first layout is simply the raw data. And if I decrease the frequency, we can see the data. And the initial running statistics digital meter. The second layout is the running statistics, as well as the minima and maxima from the digital meter that goes with it. And the third one is going to be the cumulative statistics. So they're all substantially running the same right now until the data starts to change, in which case they start to update. So what I want to do using the action module is to control these layouts to be able to display each one of these layouts in turn. And then I also want to reset the running statistics or the cumulative statistics so that you can see them reset when you need to. So going back to the worksheet view, the first thing to do is to add a control to handle the layouts. I'm going to use the coded switch. So the coded switch is a favorite because it's pretty easy to use. I'm going to set it up so that it's got 3 buttons, and each button is going to output a value. I'm actually going to set it up to be, each button is going to output a value. On the first button, I want to output the number 1. On the second button, I'm going to output the number 2. And on the third button, I'm going to output the number 3. I want to label these as opposed to use the number. And on switch position 3, I'm going to do the cumulative. It's going to output 3. On switch position 2, I'm going to give it a name, and this is going to be the running. And then on switch position 1, I also want to give it a name, and this is going to be the raw data. So what I'm going to create is a button. Let's look at the button. Here, there's the button. The button's got 3 buttons on it, and it looks better if I either have them in a row or a column. So I'll go back into the module and convince the module to give me, let's do it as a row. So I want 3 switch divisions. So I've got a row, and I can put this on each one of the layouts. So I'm going to go to the layout view. I'll create a link graph, and I'll drop the switch in underneath the date and time. Open its properties and select coded switch. Now, if you're looking at this, it's kind of tight. I'd really rather have it fill up the box a little bit, so I'm going to go to the properties directly from the layout and configure this to not display a channel name or a status display, and click OK. So now I've got raw data running in cumulative fitting nicely into that box. I'm lazy, I'll copy it. I'll go to layout 2 and I'll paste it. And I'll go to layout 3 and I'll paste it. Layout 3 somehow missed the date and time. Let's copy that over too. All right, so back to the worksheet view. I've got a button that's going to do something, and I need to tell it what to do. So I'm going to use an action module from the special group. And actions come with 3 things that you have to think about. And I always try to phrase it as a sentence. I want DASYLab to do something when something happens. So I want DASYLab to display a layout in full screen when the input value equals 1. I would like to display layout 1. Now, it turns out that I can be very clever about this. I'm going to change this to say that when the input value changes, I want DASYLab to display a layout that is a global variable, and it's a special global variable called $input, and I have to type it in. There's no shortcut to that one. So when the input value changes, I want DASYLab to switch to the layout. I'm going to do an initial screen thing. I need to do DASYLab when the measurement starts to display the layout in full screen mode, and this time I want to display layout 1. I want my initial layout. I'm going to connect that up. I want to double check the coded switch and make sure that at the start of measurement, coded switch is on the first position. So in previous releases, we didn't have a determined start value. It's nice to have it so that you have some control over how those switches work. So now I've got it set up so that theoretically, let's try this, closes eyes, pushes button. If I click the running button, it will switch to the running statistics screen. I'll go back to raw data, it shows the raw data screen. I'll go back to cumulative, and it shows the cumulative screen. So this coded switch gives me one easy control for displaying data. All right, another thing the action can do is operate on individual modules. So I have a statistical values module that is doing my cumulative statistics. It's statistics 01. If I wanted to at this point, I would rename this and say cumulative so that I can easily find it and identify it. I'll go back to the worksheet view and I'm going to add a switch. This is going to be a reset switch. And I'm going to set it up as a one-shot switch, which is initially off. I am going to label the off button as reset cumulative. And I know that I already want to turn off the channel name and the status text. And I think I also want to adjust the fonts automatically. What does the switch look like? Let's restore it. Reset cumulative comes in as a red switch. If you don't like that color, it's easy enough to change. And it resizes with the size of it. Now, I want to add an action to react to it. So I'm adding an action module. I want to, when I see a rising edge from the incoming switch, I want to tell the cumulative module to reset. This is the only thing the module can do. So it will reset the cumulative values, and I'll connect it up. I need to add this switch to the layout. So I'll go back to, probably just put it on layout 3. That's the only place you see cumulative. So I will add a link graph, and I will put the reset switch underneath, open its properties, and connect it to switch 00. And make it wide enough to read. All right. I'm going to save this worksheet. So this is statistics black box with actions. Now I'll click Start. So I'm on this view. I've got a maximum of 2.65, and the cumulative is 2.65. Now if I start to adjust the cumulative, so I'm going to increase my maximum. I'm looking at it in running, and now in the running view, I will decrease the amplitude so you can see that it's changed. And now I will go back to cumulative where it's still pegged out at plus or minus 10. When I click reset, it will reset it and start with the value where it is now. If I increase it a little bit more slowly now, you'll see the cumulative go up over the duration of the setting. Remember, we've got 2 seconds of data before it goes up. Okay. Now, these charts are a little misleading because we're above 5, so I'll do a reset again. I'll bring the value back down, and I'll do a reset again and wait a couple of seconds, and now you can see that I'm at a smaller number and they're not crunching on top of each other. So that's how the action module works and how you can use it to control your displays. I can go back to raw data, I can go back to running. Now I said that I could do some of the same thing using a key action. So I'll go back to the worksheet view, and in the worksheet view, in the options menu, you can see that there is something called key actions. When you click on it, you can select or define a key. So I'll click New. I want to define the Shift P key. So you type those keys on your keyboard to be a print function. And I want to tell DASYLab to print the layout, and you get the layout number that you want to print. So let's print layout 3. I'll click OK. Click OK. And I'll press the Start. And I had said that I wanted to print layout 3, so I'm going to hit the P key, Shift and P. You can't see me doing that. DASYLab has now printed it, and I'm printing it to my Snagit editor. So you can see that this is the layout that I just printed. It reflects the values at the time, which should still be the peak values as we look at it on the sheet. So that's how key actions can work. That's how actions can work and can give you a great deal of power within DASYLab to be able to control what modules and functions are doing. I'd like to take this same example and add a message module. The message module can only be used in conjunction with an action module, so it's a DASYLab Full and Pro feature. Message module is a way of keeping track what's happening on the screen, or in your worksheet, or to give you self notifications of things that are happening. You've got a couple of modes that you can use it in. You can set it up to display messages. You can set it up so that the window pops up. It clears when the measurement starts. It can display only the last message. It can have additional information in it. I'm going to turn off send in message, and I'm going to keep it all in a single line with a blank line between messages. And that's just style now. You'll have a sense of what it looks like when you get it started. So the other thing you can do with the message module is save a log file. You can send messages via DDE. You can play a WAV file or an AVI file as well. So we'll do the save the log file, and I'll click it up to set it to store it as a log file in the DASYLab 15 folder, and I'm going to set it up to append. And I want the send date, message number, and the time, the actual date and time, with the additional information in an extra line. What this is going to let me do is keep track of when the worksheet starts and stops. And I will also be able to send some very specific messages to it at the beginning. So open it, not the open property. So I'm going to use a new action just to separate this. Actions have to have inputs, and the message module doesn't have an input or an output. So I'll connect this action module to the switch, and I will use the input from the switch to say, when there is a rising edge, I want the message module to display a message, and the message is going to be running statistics or reset. I'm also going to create a message at measurement start that says to the message module that tells it to display a message that says starting. And I'll do a third one that will do stopping. So again, it will be the message module as the receiver. The event this time will be measurement stop. I'm going to output a message, and it will be stopping. Okay, so now, how's this going to work? There is going to be a new window on the screen. It's initially minimized. If I restore it up, it's a fairly big box. I can add this to the layouts. So let's go to the layout and make this fit. I can add it to the layout down at the bottom underneath the chart. So I'm going to add a link graph. This is still a link graph. Click on its properties and then select message from the list. I'll copy it and add it to the other two layouts in the same position. All right, let's see how this works. Let's save the file, save, and click the Start button. Oh, the action module doesn't have a connection to it yet. I jumped ahead. So I'll go back to the worksheet view and branch the wire coming off the switch into the action. Should have done that when I was saying it. All right, starting the measurement now. You can see at the bottom of the screen now, it says that we started. Now if I go to cumulative and click Reset Cumulative, I get a message that says running statistics or reset. I'll click the escape button and hit stop. And you can see in the display it shows stopping. I want to look at the files. And where are we? We're in the data folder. And I have a log file that's just been created.
Let's switch gears and finish this up with talking about starting up and shutting down DASYLab. When you install DASYLab 2020, the DSB file format is automatically configured to run DASYLab. If you drop a copy of the worksheet or a shortcut to the worksheet into your Windows Startup group, it will run DASYLab. You can configure DASYLab to auto start in the measurement menu, and you can set up actions to restart DASYLab as well as to restart Windows.
Well, congratulations if you made it this far. You survived this class. We certainly didn't cover everything, but we covered a lot of the topics that should enable you to now continue, explore, and work with your own project or projects to determine the right functions within DASYLab to use. Measurement Computing has technical staff on hand to be able to assist you if you would like any help. Contact us at Measurement Computing, www.mccdaq.com. Thank you. Thanks for taking the time to watch this.